Hello and welcome back. At this point, you should have created the Hyperion project, our very first Hello World application. Now, I understand that it may have been very confusing for you, but I hope you did your best at following along, going back and finding anywhere that you may have had a casing problem where something was uppercase and it should have been lowercase or vice versa, or you may have left off a symbol like a terminator or a closing parentheses or a curly brace. I hope you got all that fixed and you got it up and running, and you got a little something out of the general experience of creating a very simple game. Now, we're getting closer to the part where we're going to start breaking all this down and looking at it very closely. But first, I want us to make HelloWorld2, a second application. Now, the reason I'm doing this is, well, it's twofold. One, just to give you just a little bit more coding experience before we look at things at a much closer level. And number two, it gives us an excuse to create something visual. The first application that we wrote was a console app. It was all text-based, not very pretty. This application is going to be a Windows application, which means now we actually get to create a window that can be minimized, maximized, resized. But I want to make it more interesting than that. I want to put something visual on the window that says Hello World, and I want to have it move around the window. I actually want it to collide with the different sides of the window and bounce. So I want us to have some collision code, some bounce code. I want to have velocities involved. I want us to be able to change the background color of it. I want us to be able to, apply gravity. So let's show them how to do a very cheap gravity system. And let's make the object bounce around. So like the gravity is pulling it down and it bounces off the ground. And then better yet, let's deplete the energy in it and dampen it so that it finally comes to a stop. Does that sound good to you?
Yeah, it's kind of like Windows programming from a game design look or a game design viewpoint.
And this is, after all, a game design class, so let's have a little bit of fun before we start getting into the close look at code, which is coming up real soon, which is not quite as exciting as building programs. So, Logan, let's go ahead and start off by coming up to File, and we're going to create a new project. And this time around, remember last time we did a console application. Go ahead and show them that as a reminder.
Over here.
This time we're going to do a Windows application. So let's go ahead and name this HelloWorld2.
Hello World, and there we go, some capitalization.
I knew you was going to do that. Okay, so let's go and click OK. And just as we saw with the first Hello World, the Hyperion project application, we get a bunch of files all set up, except this time something new. We have a form designer. We actually have our window right here where we can come in and start putting our own controls on this window that we can interact with when it runs. To go a step further, check this out. All of the base work has been done for us. If we come up here and we run our application, check it out. It actually runs. It comes in completely ready to rock and roll. We get a window that we can move around. We can actually resize our window. We can minimize it, which it just went off into the taskbar, which you guys can't see, but it is on the taskbar. I can bring it back up. We can maximize it. All of this functionality is in place. It's there. It's done. Close button works. We have a title bar. We have the nice little 3D border around it. We have a caption on our title bar. Have the little icon in the upper left-hand corner that has menu in it. The ability to move it around, close it, etc. And all of this stuff works. It's fantastic. So really, we're ready to quickly start making some sort of Windows application. So with that, let's demonstrate, Logan, putting a control, as I just mentioned a second ago, onto our form.
Okay. Well, first we need somewhere to get controls from, and that's the toolbox. So we need to go up to View, and we need to go down to Toolbox. And that will bring up our toolbox, and just in case you didn't already have this visible inside of your Visual Studio.
Now you'll notice we've got all sorts of controls that you will probably recognize, well, at least from the control point of view, things that you can visually see on your form, things like a button, a checkbox list, combo box, a lot of these things, labels. These are things that you're familiar with because you see them on a daily basis inside your Windows applications. We see, look at this, we see them here, buttons, etc. So what I want to do, Logan, is let's start out by just putting a button on our form.
Okay. We can come over to the button, this being under Common Controls. We'll grab the button. As soon as we click on it, our pointer now looks like a button drawing tool. So if we hold the left mouse button down and click and drag, we're dragging out this little rectangular area. And if we let go, it drops the button into place.
Now we have just created an object, an actual object. As I mentioned previously, every single thing in C# is an object. Well, that means our button has to be an object as well. And as in with the real world, every object in the real world has properties like size, height, color, all that good stuff. Objects inside the C# world have properties as well. And if we look over here in our properties pane, you're going to see a whole slew of properties. Now, when creating objects, one of the most important things to do is to make sure you name your objects. So for our sake, in this particular case, let's set the name to my object.
Okay. I'll go up to the top in the property section here where we have our name, and I'll set the name to my object.
Just to demonstrate that we can do that. Now, let's go ahead and set another property, a very obvious one. Let's change the text to say, Hello World.
Okay. So scrolling back down to where we have text, and we'll change the text to say, Hello World.
And when he hits enter, you'll notice that the text on the button updated. Now, let's go ahead and address one more thing. Let's go ahead and change the size of our button. Let's make it where it is 50 pixels wide by 50 pixels tall.
Okay. Let's take our size and we'll set that to 50, 50.
All right, very good. So now, with this, next thing I'd like to do is take this button and make it do something. You'll notice, if I come up here and run our application, so here we go. Our window is indeed running and everything still works like before, but now we have a button that can be interactive with. So if I come in here and click on it, I'm interacting with it. I can push that button in, but it doesn't do anything. Well, guess what? That means we need to get a method in place. Now, with the console app, we saw that basically all of our methods, we were in charge of calling those. We'd never set up any events. But when we're working with a Windows application like this, everything's event-driven. The window's just sitting there. Well, of course, it all depends on how you code it. It could be doing all sorts of stuff. But generally, especially in this case, the window's just sitting there waiting for some sort of interaction to come from the user, like resize the window, maximize the window, click on the button. Right, Logan?
Exactly. The idea is that the application just sits there in the background doing as little as possible to save on overall computer power, CPU power,
Yep.
and wait for something to interact with it or tell it to continue working, to resize, to click, to move around, or whatever the interaction is.
So what would be I don't know, what you would think would just be the standard event for a button?
Well,
something like click, when you click on it.
So let's go look over in the events. Now we've got our properties selected. If we go change over to that, we have events.
You'll notice there's a whole lot of different events. Now, the one that it brought us on highlighted, that's our default, if you will, event. The common one that's going to happen in this case, a button, well, you're going to click on it. But if you start scrolling down, you'll notice that there are a lot of different things that can happen, things dealing with the mouse, with dragging, resizing, etc. So in this particular case, we want to add code into the event method. So how do we do that, Logan?
Well, the easiest way is just to go into this blank area where it's not set to any event right now, and double-click, and because there was no event assigned to it, it's created a new event for us, and then link that event to this method. So it's dropped down a method called myObject_click.
Okay. Now, before you start putting any code in there, I'd like to bring everybody's attention to the top down. Starting up here at the top, we have an application that looks, well, very similar to the Hyperion project application. We start off with a bunch of using namespaces. Then we come down here to our namespace, HelloWorld2. And then we start off with a class, and it's the form itself. And now there's a few extra things going on in here that we'll talk about a little bit later on. But we have our opening and our closing parentheses. And then inside of this, we've got some methods in place. Very similar to what we saw when we created just a simple console application. Now, this code just got added when Logan double-clicked on that click event for the button. You'll notice what the name of it is, private void, look at this, the name of the method, myObject, the name of our object, _click. And then we're accepting some parameters in. Once again, all of this was set up for us automatically. We can go in here and just simply start typing some code, and then what happens is when we run our application and we click on that button, this method gets fired off. So Logan, let's do something like make one of those little dialog boxes pop up that says, Hello World.
Okay, and we can get such a dialog box by using the message box. So message box, and then we can tell it to show, and then we give show the text that we want it to use inside of the dialog. And we can use something like hello world. And there we go.
Okay, so now go ahead and run your program. Just like before, everything's looking good. Let's click Hello World. And hey, what do you know? Hello World now does something when you click on it. So go ahead and click OK. And every time he clicks on it, it gives him the little message box. All right, let's go ahead and close that. Now, that's pretty cool and everything, but let's turn our attention over to the whiteboard and start turning this into some sort of simulation type application, something that looks cool, where we have a button that bounces around the screen. So coming over here to the whiteboard, the very first thing I want to do is talk about some of the properties that are about to become very important to us. So here is our button, and our button has some common properties, such as a width, a height, and we all know these are specifying the distance from one end to another. We have some other properties that are very important that determine the location of this object on our screen. And these are left, and we've got top. So you'll notice with our top left, those two coordinates will determine where the top left corner of the button is going to be placed. But we also have the ability to find the bottom and the right. And we can use all of this information to make the ball, or in this case not ball, but box, bounce around the screen. Okay? So with that, we're also going to be working, of course, with our window itself. So here's our window, and let's place our button in the window. So let's pretend that right here is 25 pixels over this way. And let's say that maybe we'll just go right here, is 30 pixels down. So if we set our left to 25, so in this particular case, left would have to be 25, and let's go ahead and slide this just a little bit, it jumped on me. And our top is going to be 30. What's that going to do? It's going to place the button right here. Now, of course, depending upon the button's width and the button's height, that's going to determine, of course, how big the button is. But we now know where the button's sitting at. Now, since I know that 25 has us 25 pixels off of the left side of our window, if I was to increment this by, let's say, 5 pixels, what's going to happen to the button? It's going to move 5 pixels over in this direction, our positive X. So Logan, what I'd like to do is let's go back over into Visual Studio and let's change our click event such that when we click it, what it does is it takes the button's left value and it adds 5 to it.
Okay, that should be simple. So let's jump over into Visual Studio. And I guess we can take out our message box now, because we want to change it over and make the box, or the My Object button, start moving. So let's start with My Object, that of course being the name of the button. And then let's take its left. So dot left plus equals some value like 2.
And remember, actually let's change that to 5 just so it's very obvious.
Okay.
And it follows the whiteboard. Now remember, like I said, plus equals. I said this in a previous Hyperion project lesson. Plus equals is the same thing as saying my object dot left equals whatever is currently in my object dot left plus this new value. So if my object dot left contains 20, after this line runs, it'll contain 25. So let's go ahead and run our application.
Okay.
All right, so button's just sitting there. When we click on it, it's going to move 5 pixels over. It's moving.
It certainly is.
Looks pretty simple to me. Now let's go ahead and prove that the top works just like left. So let's also add, how about maybe 8 to top, just so that we see it move down a little bit more than it's moving over.
Okay. So let's see, we can just jump back out here and say my object dot top plus equals 8. Okay,
now let's run it. Now it's going to move diagonally, but just a little bit more steeper downwards than it is over to the right. Okay, and look at that. And it is working.
So there we go.
Fantastic. But it would be boring to have some sort of simulation with a button bouncing around our window generated or caused by a user just clicking it over and over and over and over. That's not fun. So we need some type of control in place that will drive this position for us. I don't want to have to do it. You don't want to have to do it. We don't want to have a user do it. What I'm going to do is introduce yet another object that we can use, another component. We're going to put a timer down. So let's go ahead and close this.
Okay.
And let's jump back over into our designer and add a timer in real quick. So we'll simply come down to components, and at the bottom of components, there's timer. Now, timer doesn't have a visual control to draw on our window. So you'll notice that when Logan adds it to the form, it shows up down here in the bottom. Now, before we start doing anything with it, what I would like to do is come over here, and let's talk about the timer for a second. The timer is basically, it's kind of like this little stopwatch. So here it is, and we're going to come in here and define an interval, which is how long it takes for one tick to run. So 1 tick. The interval is going to control the tick, and we're going to specify the interval in milliseconds. So let's say I did something like 50 milliseconds. If I set that as the interval, what happens? Well, I have an event that gets fired, the tick event. So I can write a little piece of code. So here's some code. It could be little, it could be huge, however much code I want in there. And every single time 50 milliseconds comes up, tick fires. So this code fires. Now the timer doesn't stop. It continues running. So the next 50 seconds, tick fires again. Next 50 seconds, tick fires again. It keeps going for as long as the application is running, as long as we have the timer enabled. If we disable the timer, it's going to stop firing off that tick event. It's no longer running. So we can disable it when we don't want it running, and then we can enable it when we need it running. So this is a way of us generating kind of like a very cheap game loop in a way. Wouldn't you say, Logan?
Right. It's a loop in the sense that it's repeating code. It's going to repeat all the code in its tick event every time it hits its interval. It's
That's
50
right.
milliseconds or whatever you set the interval to.
So let's go ahead real quick and jump back over, if I can find my mouse here. There we go. Jump back over in here. So with our timer selected, you'll notice over here on our events area, we've only got one event, the tick. And if we come over here to properties, we've got a few different properties. Of course, the most important one being enabled. And you can see that by default, it's enabled is set to false, meaning that it is disabled. So if we come in here and put some code into place, nothing is going to happen when we launch the application. We've got to change this to enabled. And then there's our interval. So there's our 3 pieces of information we just talked about. The interval, if it's enabled or not, and the tick. So let's start off with the tick, Logan. Let's go ahead and add some code in the tick. So he's going to double click, okay, and it adds the method function right there. Okay, you say, let me change it. It's going to add the method structure. There we go. So now he can go within the open and closing curly brace and do something. And let's do this. Instead of us having to click a button to move the button, let's make its left move over automatically. So let's do something like myObject.left plus equals, and we'll go with 2, something a little smaller. Make it move a little smoother. This means every single time the tick fires, based off of the interval we set, that object is going to move 2 more pixels over on your window. So it's going to continue moving. So it's going to move to the right, nice and smoothly. Well, that's depending on how you set the interval. Let's go ahead and set the interval.
Okay, so I'm going to jump back over to the designer, make sure that our timer is selected, and then we need to switch over to properties, and then we have our interval, or rather our enable. Well,
actually, leave enabled false. Let's go to interval. Okay. What kind of interval you want to give it?
I want to give it something about maybe 16 milliseconds, so we get roughly 60 hertz or 60 frames a second.
Okay, so now leave that at 16. Leave enabled at false. Go ahead and run it, and you'll notice that the button's not moving. Good. And now let's close it. Now let's enable by setting enable to true. So we have enabled our timer, and now when we run it, check it out. Our button is moving, and now it's not dead. If we resize our window, it's still going. going and soon to be gone. Very nice. All right, so let's go ahead and close that. So very easy to set up if you think about it. Timer, it fires off every 16 milliseconds, so it's going to fire, 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 and every time it's firing, it's running the code that we put within its tick method. And that code is telling our button to move 2 pixels to the right. Simple enough. Now, let's do a few things, Logan. Let's start having a little bit of fun with this. You up for some fun? I am. How about I do this? I'm going to come in here. I'm going to grab this section right here and hit delete for me. All right, and hit Control D. Thank you. So, what if we did the following? Let's start off having our box. And we'll have our box go all the way over, and let's put our first, I don't know, a screen warp into place. What do I mean by screen warp? How about when it hits the very end right here, it then reappears back over here. So it's just going to go all the way across and like it's looping around. Does that make sense?
Okay.
So let's try that. It's kind of like our first collision check, but we're not going to bounce. We're just going to warp with it.
All right. All right, let's set this up now. We need to go, let's jump back over to our code so we have all the code within our tick event. Now, we need to do a check to see when we've actually moved completely off of the screen. So let's begin an if, and we'll say if my object dot left.
Now, and yeah, that's good though. That's good. Yep.
I'll say if the dot left is greater than, now we need to get that client area we were talking about.
Yeah.
And that's a property of the form that we're in. And because we're within this form here, we can use the keyword this and say this dot client size. So there we've got our client size property, and we can access width from within client size. So if we've got our left being greater than the client width, then we know we've gone off the edge of the screen and we need to perform a warp. So we can do something like set
Let's just set it to 0 for starters.
Okay. So set my object dot left to equal 0. So
okay.
Set it back over to the left.
Don't run it yet. Now let's think about what he's doing right here. Basically, we are performing a check, and we're waiting to see just as soon. Let's pretend that right here is 150 pixels, and that's to the edge of our client screen's width. And let's say that right here is 151. What we're doing is we continue to check until the moment that the left side is greater than our width. And the moment it is greater, then what we're going to do is we're going to set this left side value to 0. Well, where's that going to put us? That's going to put us all the way back over here. So we're just going to we're going to smoothly slide off the window, but then we're going to snap back to right here. Okay, so let's give that a shot, Logan.
All right, let's jump back over into Visual Studio, and we'll run.
So here we go, and we smoothly scroll off, but then we snap back, as opposed to pink coming right back on. So let's see if we can adjust our code to make it look like we smoothly scroll back on the left-hand side.
Okay. So more or less what you're saying is we need to compensate for the fact that our object has width.
Right.
So we need to go that far off the screen so that we slowly slide onto the screen. So we could do something like saying, well, let's think about this. If our object, earlier we set the object to being 50 pixels wide.
Right.
So that means we would need to go back negative 50 pixels, so that we're 50 pixels off of the screen, and all of our width is off the screen then.
Okay.
So we need to set it to negative my object dot width, because obviously we couldn't set it to positive 50, or we'd have a 50 offset instead of being 50 pixels off of the screen. So negative my object dot width.
Which isn't that going to be the same thing as saying 0 minus my object's dot width? So it's going to start us 50.
So at negative 50.
That's right.
And that gives us enough room to account for our width.
Which will make it look like we are smoothly scrolling into the window. So here we go, smoothly off, smoothly back on. Very nice, very nice. I say step 1 complete. Let's go ahead and close the application, Logan.
Whoops, wrong button.
There we go.
Just kidding.
My kind of close. Haha, I like your joke. It was very funny. Okay, so now that we are doing the warp, so we'll say this was our warping. Now let's do this. How about we put our first bounce code into place? We come all the way over, and the moment our right side of our box comes into contact with the wall, let's turn back the other way. Now the fun thing about this is this turning back the other way is going to force us to change our code just a little bit. Because now we need a number that we can turn around, because if you recall, at this point what we've continued to do is simply add a number, a positive number, to our dot left property. And by adding that, it's just done nothing more than pushed us to the right in our window. So we've always gone to the right. Even when we warped around, we continue to go to the right. But the moment we need to go back in the opposite direction, aren't we now subtracting some number away every time?
Right, because our left will have to get less and less smaller in order to move in the left.
It's quite easy to see. I mean, if right here is 150 pixels and right here is 25, the number got smaller when going in this direction. So to do this, we're going to go ahead and put a velocity into place and hold a velocity number. So that's going to sound scary to some of you guys at first, but watch this. Go ahead and switch back over real quick.
Okay. Let's go back up to the top of our code right before our constructor so that we can put in a variable, so we can store a velocity.
Okay.
Let's define this variable as private, because we're only going to use it inside this class. Well, to say that it's a float variable, because we're going to need the accuracy later.
Meaning that it can support decimal numbers.
Right. And then let's name this variable velocity x.
And let's go ahead and initialize it to 2. Or what are we using right now? Are we moving over 2 every time?
I think we're doing 2.
Yeah, so see how we're going 2 every time? Let's go ahead and initialize that to 2. So we're going to get the exact same effect here in a second. Now, let's go ahead and scroll back down. And instead of saying plus equals 2, let's say plus equals velocity x. Now, there's a problem with this. Before we do anything, if we start to run this, we're going to, well, basically during the build process, get an error. Because velocity is of type float. Remember, we declared that right there. It's a float. And also, we have dot left, which is of type integer. So now we have 2 different types of numbers. This type of data is a whole number. This type of data is a decimal number. So just go ahead and show them, Logan, if you tried to run the program.
All right, if we try to run, then we get a build error, and we cannot implicitly convert a float to an int.
So we need to convert the float over to an integer. This means we need to cast this variable. So just follow along. Here's how we're going to do that. Parentheses, int, close parentheses, butt it right up against our float variable. We'll take that number and convert it over to an integer value. So basically we're going to get rid of the decimal portion of that number. And this will now be compatible. So now let's try running it.
Everything builds and we begin running.
It looks exactly like we had it a second ago, but now we have velocity into place, and this is where we can start getting fancy and make our button go the opposite way and make it look like it bounced. So let's go ahead and close that. Let's set that up.
Alright, so we need to do, this is still a good check. Well, actually thinking about it, it's not
a good check, because this check never became positive until the box slid all the way 1 pixel off of the screen.
Which would mean it would still slide all the way off of the screen before doing a bounce.
You know what? I got a great idea. How about we leave it just to show them what it's going to look like with it sliding all the way off before it does the bounce.
Okay. So for just a moment, let's focus on only the bounce itself. Let's focus on reversing velocity. So we want to take our velocity x. Now, the easiest way to reverse it would be to simply multiply it by -1. So velocity x times equals -1, so we should start moving in the other direction.
Meaning that when we come in with a value of 2, because that's what we start off with in velocity x, when this check right here in the if statement becomes positive, or excuse me, true, then we're going to do this code down here, and this code is just going to say take whatever's in velocity x, which is 2, multiply it by -1, and store it back in velocity x. That means -2 is stored in there. So now each time around we're going to add -2 to our number, which is going to have us going in the opposite direction. Let's go ahead and run it. So here we are, and we're going to slide off the screen, and then it's going to look like we bounce back. But we kind of lose the sense of a bounce because it slid off the screen first. So let's go ahead and check for it hitting the right side of the button as opposed to the left.
Okay. So we can take our object's right property and check that against the client's width. So here we go, watching the right side,
Dink.
and then we bounce off of the right side of the button.
Very, very nice. All right, let's go ahead and close that. So now, back over here, we have simple bounce in place. So now what I'd like to do, let's go ahead and put a little bit more of a complex bounce. Let's go ahead and watch for hitting this wall. And then when we hit it, let's go back in this direction. Let's watch for this wall, and then have it turn back around once again. Okay?
Alright, so that means we need to do an additional check. After we check to see if we bounce on that wall, well, if we didn't bounce, let's do another check. So let's put in an else. And we'll do this as an else if, because we need to do another check. And for this check, let's check our, my object. This time we want to check its left, and see if the left side has hit that side of the client's area.
And that side of the client's area is simply 0.
Oh yeah, rather. We want to check is less than 0, because 0 being the most left side of the client area. So if we've gone off of that, so we're less than 0, then we again need to reverse our velocity x. So we can again multiply by -1. And looks good. So
okay, so let's give that a shot. That looks good.
And that looks good.
Okay, so now we are bouncing back and forth. Very cool. So with that into place, let's go ahead and change this a little bit more so that we now introduce a velocity in y.
Okay. Because, yeah, we want to have movement in 2 dimensions. That would just be kind of nice. So let's take our definition for velocity x, copy the entire thing, and then paste it in right below, and simply change the name to velocity y. And maybe change the value as well. Maybe have it start out at 5. Now, let's go and implement this. We need to move our object, of course, by velocity y, but we need to move our object's top instead of left because we want to move vertically instead of horizontally. So we can simply copy the line where we're advancing our left, paste this in, and we'll change the left property to top. So we're taking our myObject.top, and we're adding to it whatever velocity is held in velocity y.
And we can see right away that this is working if we go ahead and run the application, and it just runs off the screen down below. Okay, very cool. So we're going to need some checks in there to go ahead and catch this.
So let's type out another checking block.
Okay.
Where we do similar checks as before, except now we're checking for things like top or bottom, and client size is height instead of its width. So the first check, let's check against the bottom since it hits the bottom first anyway. So let's see that if the myObject.bottom is greater than this dot client size dot height. And if so, let's reverse our velocity y. So multiply it by -1, and with that should work for our bottom bouncing check. So we look, and it is indeed bouncing.
Very nice.
And then flies off the top of the screen.
Now you could write this if a little bit different, where it was just all one if, where it was if were this or were that, since it's the same piece of code.
Meaning just do another if?
Or just an or. Logan loves when I change things on the fly.
You're saying this condition again, so we could add, so if it's greater than the height, or myObject.top is less than
0.
Then we reverse velocity.
Yeah.
And just to make this a little bit clearer, I'm going to do what I should have done before and just block all this in.
Okay.
The reason I didn't is because it was only one line for now, but
I just want them to see another way we could throw this out. So nice. Ooh.
I see where you did that, because in either case, whether we're bouncing off the left or right,
we're performing
or the top or the bottom,
same thing.
Yes, it's the exact same operation.
Now watch this. Go ahead and resize that while on the fly. Check it out. Isn't that cool? Yeah, it's not going to update until you let go. Very nice. Sweet. So let's go ahead and change the if line above. Now that they've seen the logic written out 2 different ways, I definitely like using the logical operators down there. So let's go and put ors in the first group as well.
Okay. So same type thing. I'm going to put an or after our first check, drop down a line, and then we've already got our second check written here, so I'm going to cut it, paste it in, and I'm going to block the section. And again, I wouldn't necessarily have to block it. I personally think it'll just make the code look a little bit easier to read in this case.
There we go. So all we're saying is, and if I was to come in here and take a look at this, is if the right side is greater than the width of it, or if the left side is less than 0. So in either case, if we're hitting the ends, just flip the velocity. That's it.
Right. It's more or less saying if we have encountered a horizontal bounce reverse the velocity.
Precisely.
But reverse the velocity x. If we've encountered a vertical bounce, reverse the vertical direction, which is velocity y.
All right, very cool. Now, we've got that into place. I'd like to have the background color change, sir, each time that we come into contact with the wall. But let me throw a little challenge at you. Let's start making this a little bit interesting. Let's start modularizing things a little bit. Let's start breaking up some of the functionality into their own methods so that everything's not just being stuck in the timer thing.
Right, because the timer event is actually growing quite considerably now. We've got checks as well as velocity increment going on. So how do you want to break this out?
I would do something like this. Let's start out with an update scene, because we're going to end up with an update scene or something similar to update something in all of our games coming up real soon. So let's do it ourselves. And in our update scene method, let's take care of, well, utilizing the velocity to move our object.
Okay. So first let's define an update scene method. I'll define this as a private void, because we're not going to return anything, and we'll call it update scene. So we have our method. Now inside of update scene we want to move our object around. So I'll take these two lines where we're moving our top and our left and incrementing them. I'll cut those and paste them into update scene.
And throw me a double line comment above those two that say move object.
Move object.
So it's just a note left for us. You know, if we come in a week later, it's like, what were we doing? Oh, we were moving the object. Simple enough. And we're going to talk a lot more about comments coming up soon. All right, now that we have an update scene, how about we have something like check wall collision and move all of our ifs into that method?
Okay. So let's have another private method, again, returning void. And let's call this check wall collision. And let's take all of our collision code now, grab all of that, cut it out, paste it into our check wall collision, and there we go.
All right, so now every time our tick fires, we need to update our scene.
Right, so let's call our update scene method.
And we're going to need to check for wall collisions.
So down in update scene, let's go and do the check.
And
So
that's really up to you if you want to structure it that way.
Right, that way we can start looking at update scene as the heart of all of our interaction and movement. And so that's where we move the objects, and then we can even throw down a comment before they say check for collisions with the form walls.
Okay.
And then that, of course, just means that we run our check wall collision method.
All right, very good.
Looking good so far. And just to test this restructure, we can go ahead and run the game and make sure that we're still getting the same results. And we've got a moving object, and it bounces off of the walls.
Very cool. And I'm starting to breathe a little easier. I'm starting to like the way this is looking now. It's being structured a little bit better. And it makes a lot of sense. Again, go ahead and close that, Logan. The whole idea, ladies and gentlemen, is simply to break this up into very precise, logical things that are being completed, tasks. Updating scene, we need to move our objects around and check for collision. Check for collision has been isolated to within this method. Here's check for collision. What's nice about doing it this way is when we have a problem with our code, we know exactly where to go and look. So it allows us to just fine-tune and focus on a specific area.
It also allows us to do problem diagnostic in larger steps, meaning that we could start looking at update scenes, saying, okay, our program is doing something wrong. What do we need to check for? Let's check moving. Okay, we move. That's okay. And then we watch the program break at collision. So, okay, we have a problem with collision. Where's that? Okay, we look through here. That way we don't have to look at the code as a whole. We can look at the individual steps first, and then just deterministically decide what's actually going wrong.
Precisely. And we get one other nice thing out of it, too, and that is we get the ability to expand on that particular functionality easily since it's been modularized into its own method. So in this case, we can kind of see that coming up here like right now. Let's have if a bounce occurs, it's going to change colors. But let's have the changing of colors happen in another method all on its own. It's called something like process bounce.
Right. Or rather, let's set it up so that we have a method that gets called on every bounce.
Yeah, that's what I'm saying.
So that means we need to define a new method. This time, private void process bounce.
Now let's go ahead and have it actually take a parameter in this time. Let's have it take a color in.
So basically, we want process bounce to be visually reflected by a color change on the form. So we're going to tell process bounce what color it should use to show this bounce.
Right.
So I'll define a parameter called color, and it'll be of type color. So let's block in the method. Now what do we want to have happen when a bounce occurs?
Okay, we want our Windows background color to change.
Okay. So then we have our form, which can be referenced with this. And we have a background color property, which we can set to whatever color was given to us. So we take this color that was passed into process bounce and then set that as our background color.
Okay. Now, this is where it's going to get interesting back up here. Let's just send 2 colors over at the moment because we only have 2 areas, 2 specific areas. Whether we bounced horizontally or we bounced vertically. So if it's red or if it's green, we'll know if that was caused by what last, a horizontal bounce or a vertical bounce.
Okay. So let's say for a horizontal bounce, we'll process bounce, and we'll feed it. Which color do you want for horizontal?
Let's feed it, I don't know, blue.
Or you said red and green, out of red and green.
Oh, red and green. Okay, I don't know. Pick one.
All right, red. Just because that comes to mind first. And we access colors by using color itself. So color dot red.
So red it is.
And for vertical bounce, we'll process bounce as color dot green.
Now, looks good.
All right, let's run.
I was going to add something else, but I decided not to.
Green bounce,
Ooh.
red. Green for vertical, red for horizontal.
Now, as a challenge for you guys, figure out how to make the color change on all the walls. It's not that bad. Okay, so let's go ahead and change the button, or my object's color, so that it's just a regular button face color. Again, this is going to be a property.
So we need to jump over to properties, and there we saw back color just a second ago in code, but we can also see it as a property over in the properties section of the UI. So we can go into back color, and we can change that from control over to button face, so that it always keeps the button color.
Right. So now if we run it, much better. All right, very cool. So now we have that in place. All right, let's see. Let's start having a little bit of fun. We made our velocities floats, which we'll be using very soon here. Let's go ahead and start putting some gravity in.
Okay. So just to start with a application of gravity, let's go into our update section of the code. Let's say after we check for collisions, let's add, or more or less add gravity to one of our velocities. Since gravity, of course, affects how things go up and down, that means we'll be affecting our velocity y. So let's take a look at this. We'll take our velocity y, and every time we update the scene, let's add a value of 0.5 to it. Again, adding means going down, because as we add to it, we get farther down on the client area.
Precisely.
So we'll add a value of 0.5. I'll specify f for a floating point value, and then a terminator. So every time we update, let's take our velocity y, and let's move or increment it in the down direction by about 0.5.
Okay.
So let's try this, and there we go.
Look at that. It's bouncing. Very cool. And changing the background color. And bouncing. And, oh, this is a good one. Go ahead, Logan.
That was an interesting problem. We had the object just kind of flicker at the bottom of the screen and eventually slide off. So what was the deal there? What was the deal with the thing flickering up and down or bouncing up and down really fast?
Okay.
Well, if we look at the code and what's actually happening on every bounce, let's look at vertical bouncing. Whenever we have determined that we're off of the screen, we simply set the velocity. We don't reset the position.
This is where we're going to have to change things a little.
Yeah, we're actually going to have to change it back a little bit.
Yeah,
because
we are.
We need to go back to being able to tell which side of the client area that we went off on.
Yeah, the problem is this. Let me show this real quick. This is what I get for changing things on the fly. Let's say we're checking the code to see if we have, like this box right here, right? So we're over here and we're off. So what I want to do is I'm drawing at a funky angle. There we go. Let's say that, again, this one's at 151. Actually, a better example. If we're moving back this way and we're checking for the left side of the box to be anything less than 0. If it's less than 0, where's the box? It's a little bit off the form. What we really need to do is immediately snap it back to 0. As a matter of fact, Logan, if you want, you can demonstrate this quickly just with the button move. Nah, they can visualize it. They can visualize it. This isn't bad. So what we want to do, though, is if the button has actually moved past, which means we need to do the bounce. But before we do that, let's go ahead and snap the button itself back to 0.
Right, because what's happening is if we go a little bit off of the form, all we're doing to get back onto the form is we're just changing velocity, and we're relying on velocity to carry us back onto the form. But what's happening every time that the control is less than 0? We're reversing. We're not telling it to go in a direction. We're telling it to reverse its direction. So let's say we slide somewhat off of the form. Then we reverse our direction, and that reversal isn't enough to carry us all the way back onto the form. We're still overhanging a little bit. We reverse our velocity again, and we jump back. We reverse the velocity again, and that again doesn't give us enough movement to get us back off the edge. So we sit there and just flicker back and forth with the velocity reversing every single time it updates.
Right.
Whereas if we do what you were saying, if we snap it back to the side, then the velocity is going to carry, or the velocity doesn't have to carry us back on. We're already back on the form.
Exactly.
So let's jump back into code. And what do you want to do first? I guess we need to break this back up so we can tell which direction we went off in, because we need to see if we went off the left side, we need to be snapped to the left side. If we went off the right side, we need to be snapped to the right side.
Right. Yeah, and that's good. It just gave them, a chance to see a different way about, going about things.
All right, let's take this back into its own if. I'll address the rest of it here in a second. So we'll block this in, and then I guess we can feed in an else into the other one, so else if. So that simply breaks the conditions back apart. And we need to copy some of our code, so I'll simply copy our velocity x reversal and our bounce processing.
Oh, now you can go ahead and change the colors all the way around, so we can have all 4 walls do something.
Right. Before I do that, though, we need to get the position resetting put in. So if our right has gone off the side of the screen, that means we can take our my object, set its right, if I can spell, to just snap it to the client size.width. So I can paste this in. So that's saying take the right. Basically, if the right has gone over the side of the window, snap the right to the size of the client area. And then do our velocity reversal and our color processing. And we need to do the same thing for left. Or my object dot left
just set it to
is
0.
equal to 0.
Okay.
So we snap back to 0, and then we continue on. And you said you wanted to change the color so that we can tell the difference.
That challenge went out the window.
So red, let's have left be blue.
Okay.
And let's do the same thing for vertical bounce. And now let's break this condition back up. So we take our greater than height check, make that its own check, jump down a little, replace this with an else if, and block in our section for our first check, bring this back up, and we're good to go. Again, let's steal the vertical bounce from below, paste that in, and let's add in our snapping. If we went off the bottom, we need to snap to the bottom. So my object dot bottom is equal to this dot client size dot height. And let's see, let's have bottom be represented by orange.
Okay.
And now we need our one last snap for the top. So my object dot top is equal to 0.
All right.
All right, let me do a build, make sure I haven't introduced any errors, and I have managed to introduce errors. So let's jump to here. Okay, I see what's going on. Right itself, if you think about it, setting right would technically affect the width instead of affecting the position.
I was actually wondering that when you type that out. It's really, that's just giving us information. We need to work with our left.
All right, we need to set the left, but we can't set it to the width, because if we do, we get the same problem as we did earlier in the scrolling check. We actually scroll all the way off.
So it needs to be that minus the...
Right, we need to set our left, but we need to set our left. Basically, you can think of the right as the left plus the width.
Of that object.
So that's of the object, but if we want to offset that, we can subtract it from the client area's width. So we can take minus my object dot width, and then scroll back on. So Let me do a build on that. We're good there. And I used bottom. I was trying to set bottom. Same type thing. You can't set bottom. It's read only. So let's set our top. Can't set our top because it'll look like it scrolls off. So we have to account for our own height. So we just subtract this object's height. So my object dot height. Subtract it off. We can build now. And do you want to go ahead and test it?
I was just going to say, just in case they were confused with that, because that may have been like, what was he talking about? So here's what was happening. Basically, this represents the right-hand bottom side of the window itself. So what Logan had done was, if we got over here and let's say that part of the button had gone off screen, like such, right? We need to snap it back so that the button looks like this. But the right property is read-only. We can't actually write data to that. What we can write data to is the left, because remember, like I said earlier, for setting where an object is, anywhere on, basically its location, anywhere on the window, we set its left and we set its top property. So that's what we need to set. Well, we can't just say take the left and set it to the width. Like, it'd be nice if we could take the right and say set it to the width, because if we did that, where would the button really be? Well, the button would actually be starting right here, and it would run off in this direction. So what Logan did was he said, basically set it to the width of our client space, our screen, minus, and then he took the width of the button right here. And what that did is it backed our button up. So here's where left became, and then it looked like right was indeed touching the edge of the window.
Kind of similar to how when we needed to have the scroll effect appear off screen, when we were doing the scrolling version,
same thing. Yep.
We had to set it to its negative width, so 50 pixels offset.
And the same exact thing applied in the vertical direction as well, because, again, we couldn't set the bottom, so right here, to be the height from top to bottom of our actual client space, once again, the height of it. So we have to set the top, which would have pushed us down here like such. So to back us back up, all we had to do was subtract away from that to get back up here the height of our button. And so that's what's going on.
Exactly. So let's check and see if that is indeed the case. So let's run.
Good.
And we're good there. We're good there.
And so, yeah, now you can just keep watching. It's going to bounce, 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 and we're never going to get any of the really crazy flutter we had a second ago, because we won't have an opportunity arise where we're stuck a little bit past and we get caught in that situation where velocity reversing us back and forth keeps us past the edge of the actual window.
Right. Every time we process bounce, we get snapped back onto screen before we start processing by velocity again.
Yes.
So we don't have a chance to get that velocity reversal flicker again.
Yes, and we have a bouncing box. How cool is that? Very neat. Now, how about if we want to dampen that?
So you mean as it's bouncing, have it bounce less and less and eventually appear to come to rest?
Yeah.
Well, in order to make it do that, we need to start taking away from our velocity with each bounce. So it bounces a little bit lower and then a little bit lower again. So let's see. Since we've got our process bounce, we kind of have a nice generic area, or general area that we have happen out on every bounce. Let's say that every time we bounce, we take a little bit of velocity y away. So let's take our velocity y, and let's just multiply it by some value less than 1. Like, let's multiply it by 0.8, and then we'll say that's a floating, so 0.8f. So every time we hit process bounce, we should have our we should only have 80% of our velocity in y.
Okay.
So let's try this and bounce, and there we go, and slowing down. Though our velocity x
continues,
so it looks like we keep sliding.
We're on ice, yeah. So we could go ahead and do the same thing for x as well.
So we could take our velocity x,
and just set it to 0.82.
So 0.8f.
Okay.
And now when we run, we slow down in both velocities in both directions and eventually come to a rest.
Very cool. Well, so, Logan, that's pretty much everything I wanted to do. If they don't mind, which they can't really say anything right now because, well, they're just watching a video. If you don't mind, how about we do a little bit more?
Okay.
How about just this is just total bonus material. How about we do some sort of, when the mouse enters the buttons area, the buttons text changes to say apply gravity. And so gravity is never applied, and the dampening, until we basically press the button. And that turns gravity on. And so that applies gravity.
Okay. Let's see. Let's do that one piece at a time. Let's just do the text changing first.
Okay, guys, if you could have seen the look Logan just gave me. No, I've not lost my mind. It'd just be fun. Come on.
All right. Well, first things first. Let's do the text changing, and then we'll put the functionality in behind that.
Okay.
Let's go. So we need to have a whenever the mouse enters this button area, change the text to apply gravity, and then if we happen to move the mouse off, let's change it back to hello world. So let's jump down to our mouse enter.
Okay.
Inside of our mouse enter event, let's take my object, of course that being the button, setting its text to equal apply gravity. And then let's go back over to our button in the designer. Now let's take the mouse leave. Let's make an event for that. And we'll say my object dot text equals back to hello world.
Very cool.
So let's run this, and as we hold the mouse over, it says apply gravity. So if we move off, hello world, apply gravity. There we go.
Very cool. Let's go ahead and close that out. Now let's put the functionality into place.
All right, we need to have since this is essentially turning gravity off, we need to be able to check at any given time whether or not we actually have gravity turned on.
Okay.
So let's jump up to the top, and let's have a variable set so that we can remember whether or not gravity is turned on. So let's make a private Boolean value.
True or false.
And let's say call this gravity active. And let's initialize it to false. So we begin with gravity being off.
Okay.
So gravity active set to false. Now we need to have the rest of our bounce code respect this. So the first piece of bounce code is in our update scene. As a matter of fact, let's comment that so it makes it apparent what this is doing. We'll call this apply gravity. So as we're applying gravity, we only want to apply gravity if we have gravity turned on, so we need to do a check. Let's check that gravity active value. So if gravity active, apply gravity.
Okay.
Otherwise, we won't apply gravity.
Okay.
So the other thing that we want to do is we don't want to have the dampening run because let me actually run this and show what's going to happen. So what
we're going to need to go up to the button real quick and add that in.
Well, you see, every time.
Okay, yeah, that's right, because the other one's
every
false
time we
by
do
default.
a bounce, even though we don't have gravity applied, we have that dampening still applying. So we're going to stop either way.
Right.
We want to have it set up to where the object will continue bouncing until we apply gravity, and that simply means we need to take our dampening and have that only in effect as long as gravity is active. So we'll do our check again. So if gravity active, we apply dampening. So I'm going to block this in since we have multiple statements inside of it. And now if we run, we keep our speed continuously.
Very nice.
Now we need a way of turning gravity on.
And off. I want to toggle it.
Okay. So let's say, what were you saying? You wanted to have the button click is what actually turns gravity on and off?
Yeah.
And we should still have the button click because we were using that to test motion. So way back up here we have our my object click. Let's just delete out where we were moving it since we've already got update scene and things like that for handling movement. Let's instead use the click to toggle the gravity. Because, I mean, we could just do something like gravity active equals true to turn it on, but you're saying you wanted this to be a toggle instead.
Right.
So let's use the not operator, since not reverses a Boolean value. So what value do we want to reverse, or toggle? Well, we want to reverse gravity active.
So not gravity active is going to always be the opposite of what gravity active currently is. So if gravity active is currently false, it becomes true. If it's true, it becomes false.
And thus acts as a toggle. So we have a way of affecting the toggle, so we should be able to try this out. Here we have our bouncing. So we're bouncing normally, no gravity, until I click the button, and then
it just falls.
I want to take some of the dampening off of X if you don't mind.
Okay. No,
because it seems to be ultra crazy friction.
Change it to like 0.95 or something.
I think 0.9 will take care of it.
Okay.
So here we go. Normal, normal. Let's turn gravity on. Whoops, missed. There.
There we go.
Still not exactly perfect, but I mean we can tweak velocities and stuff like that. But there we go. Now we've never actually told this button to bounce, so if you look at it really closely, you might actually be able to see it vibrating a little bit. And we can demonstrate that by resizing the form now. If I resize the form down, we're still constantly calculating for the size of our client size.
But what's really cool is if you click the button again and pull it down, there we go. Either way, it doesn't matter. It's since we just turned gravity off, now it's like it's weightless. Now it has weight, now it's weightless. Woo! There you go.
There we go.
Well, that's going to pretty much wrap it up, Logan. Anything else you want to add into this?
There's only one thing I want to do, and that's just to clean up the code a little bit. I don't like how the code has become a little bit messy as we were working on it. And what I mean is, we started out with some events that we set up. Then we added some of our own methods. And then after we got done adding those methods, we added some more events. So we kind of go back and forth between events that got added and methods we wrote. So what I want to do is group all of this together so that all the events are in one place, all the methods are in another. So let's take our events that we added for the mouse enter, mouse leave. I'm going to cut both of those, move them right below our events for click and timer. So paste those in, and then to make it even clearer, we'll put regions around these so we could collapse either one of them if we want to hide them away. So let's start a region. We'll call this events. And go to the end. Let's end this region. And we'll start another region for our methods. And end that region down here. So now, let's say we're working on our methods, we don't need to see anything with events, so we can collapse that down, or we can collapse both of them down. And then we have the code, nice, concise, easy to read.
Very nice, very nice. Well, guys, that's pretty much going to wrap this video up. This is our second Hello World application. This time around, we're doing a Windows application. It was all visual. You got to see how it was all event-driven, based off of the event coming from the tick on the timer, the event from the click on the button. So it kind of exposed you to something a little new. But you saw that the code was very, very similar to what we were working with. The structure and all still looked exactly the same when we were working on the Hyperion project. So with that, that's pretty much going to conclude just this really quick type intro to playing around with code. And from here, we're going to start getting a lot more specific on what exactly .NET is, C# is, how structure is set up, what objects are, etc., etc. So that is going to wrap up this video. I encourage you, of course, to follow along with everything that we did and play with it. Try to have a little fun. See if you can change it around a bit. Make it a little more interesting if you can. And with that, that's going to wrap it up. Thanks a lot, guys.